Hello, this is Professor Merrill Lichty. In this video, we'll be solving problems involving the sample mean, which means that we need to know what the distribution is for the sample mean. And looking back at your notes in the textbook, let's set this up. We'll say that x is a random variable with mean mu and standard deviation sigma. If that's so, then x bar is going to be the average or the mean of a random sample of n x values. And the sampling distribution then of x bar has the following properties. And as you think about this, think of what's going on here. We're taking a sample of size n, computing the mean, and then we're doing it again for a different sample of size n, and again, and again, and again. So every time we take a different sample, we get a different value of x bar, and x bar then has a probability distribution. And the mean of that distribution is the same as the mean for x. So mu sub x bar is equal to mu. Standard deviation is related to the standard deviation of x. So standard deviation of x bar is equal to sigma divided by the square root of n. And if x is a normally distributed random variable, then x bar is also normally distributed. If that's not the case, then as long as n is greater than or equal to 30, we have the result from the central limit theorem that x bar will at least be approximately normal. And the central limit theorem is nothing short of miraculous and one of the most used and useful theorems known to man. So what are the steps that we need to go through in order to solve questions about the sample mean x bar? First of all, we need to check to see if x bar is normal. And if it's not, then we need to stop at that point and consult a statistician or look to some of the other things that we're going to learn later in class. If it is at least approximately normal, then we need to calculate the mean and the standard deviation of x bar. And then once we have that, we already know how to find probabilities associated with normal distributions because we've learned those already, so we just need to apply those to that problem. So let's look at the step one. If we have IQ scores and we are told that they are normally distributed with a mean of 100 and standard deviation of 16, and we're going to sample 5 people at random, and we want to know what the probability is that their average IQ exceeds 110. Can we do that? Well, it turns out yes we can, because we know that x is normal, so that means x bar is going to be normal. Example 2, the lifetimes of Toyota truck engines to a major overhaul tend to follow a right skewed distribution with a mean of 210,000 miles and a standard deviation of 40,000 miles. So if it's right skewed, that means it's not symmetric, it's not normal. And part A says, what's the probability that a single truck's engine lasts longer than 250,000 miles? Can we answer that question using the normal distribution? The answer is no, because we don't have a normal distribution. What about the average engine life for 10 randomly selected trucks being less than 200,000 miles? Again, we cannot use the normal distribution for that because 10 is not big enough, and we don't know what the underlying distribution is, only that it's right skewed. So that leaves us to part C, which says the average engine life for 40 randomly selected trucks is greater than 225,000 miles. Can we do that one? Yes, we can, because our sample size is bigger than 40. Doesn't matter what the underlying distribution is. So let's look at the solution to question 2C. We've got that restated here. So solution, step 1, is it normal? Yes, we checked that already. Step 2, calculate the mean and standard deviation. Then the mean is just the same as the mean for x, which is 210,000 miles. The standard deviation for x bar is going to be sigma divided by square root of n. So that's 40,000 miles divided by the square root of 40, which is 6,325 miles. And so now we know the mean and the standard deviation. We know everything we need to know in order to answer the question at hand, and that is, what is the probability that X bar is greater than 225,000 miles? So we have this picture, and we can use Minitab or Excel or the table or whatever you want to do. We're going to use Minitab here, and we're going to use cumulative probability. And remember that cumulative probability is the left tail, not the right tail. So when we put this in, we're not going to get exactly the right value, but we are going to get 99.11%, and that's the area to the left of 225,000. We want to know what's the probability of being to the right of 225,000. So we just have to subtract that from 1, and we get about 0.89% is the probability the average truck life for a fleet of 40 trucks is greater than 225,000. And that's all we have for this video.